DC circuits, VI characteristics of power sources. So now basically we will be discussing VI means voltage and current characteristics of power sources. Like power sources can be either a voltage source or a current source. So how the voltage and current graph looks like for a DC circuit. So let us suppose I have a DC circuit in which I have a power source. Now how the VI graph will look, that we will try to analyze. So VI characteristics of voltage sources. So let us suppose I have a voltage source, a DC voltage source I have. Now how the VI graph will look in an ideal scenario and in a real scenario. Let us try to identify. Let us try to analyze. So let us suppose in here we can see we have a voltage source, capital V. Definitely these points A and B, they will be having a potential difference, and we are saying it to be VAB. So let us suppose VAB is the potential difference. Now it's an ideal voltage source because no resistance is there. See, in real life, there will always be resistance present along with the voltage source. But here we can see there is no resistance. There is no resistance. Since there is no resistance here, we can't see any resistance now. We can say it is an ideal voltage source. So this is the scenario for ideal. So for ideal voltage source, for sure, with time, because this x-axis is the time and y-axis is the voltage. So voltage will be constant because this is the ideal voltage source. Like I have an ideal battery which will keep on giving constant voltage forever, but it doesn't happen. Like if you have a clock, after some time, you will see you have to change the battery because the battery gets discharged. But ideally, if I talk about ideal scenario, with time, it will be constant. So this is very clear to us. Similarly, we have real voltage source. In real voltage source, what happens is there is a resistance always. And in real life, we can't get rid of resistance. There is always a resistance. So this is the resistance. So along with the potential difference, like the voltage source, we have a resistance in series, because of which what will happen with time, voltage, the voltage supplied or the potential difference, it will not be constant, but it will keep on decreasing. And after some time, it will become zero. That is the time when either we have to change the battery or we have to like charge it because of this resistance. Because this resistance is basically dissipating the energy. Because what is voltage source? Voltage source is supplying energy. If that energy is getting dissipated, it means that the voltage will not remain constant. With time, it will keep on decreasing. So this is a very important analysis we are doing. So this is the VI characteristics of voltage sources. Similarly, we have VI characteristics of current sources. So let us suppose this is the current source I, and here we can see there is no resistance present. No resistance, so it's the ideal current source. It's the ideal current source. It means that with time, the value of the current will remain constant. It will not change. With time, the value of current will remain constant. It is the ideal current source. Similarly, we have here one more current source in which resistance is connected in parallel. And since resistance is present, it can't be an ideal current source, but it will be a real current source. Because in the real world, we will definitely have resistance. So this is the real current source. So now one more very interesting observation we made: with current source, resistance will always be with the parallel, and with voltage source, resistance will always be in series. Very important observation I'm making. This will be very useful in numericals. Like whenever we will be having voltage source, resistance will be in the series, and whenever I will be having current source, resistance will be in the parallel. So now, since it is a real scenario, with time, current will not stay constant, but current will keep on decreasing. So this is the VI characteristics of current sources. So if I basically combine both the analysis, right? So if I talk in general, VI characteristics of power sources, then I can say that the VI graph, ideally, it should be like voltage should remain constant. Ideally, voltage should remain constant, and like I can have different current that should remain constant. Like I can have different voltages that should be a like straight line, should not vary, and I can have different current that needs to be constant. So this is the ideal scenario. So whenever I will plot an ideal scenario, so definitely I will be having some horizontal line which will indicate that okay, voltage like different voltages I am having that will be constant with time, like V1, V2, V3. This is the, and similarly I will be having different currents which should be constant. So this line, because with time current shouldn't change. I1, I2, I3. Okay. And let us suppose this is the, but unfortunately this doesn't happen. So what exactly happens is in the real world, because of resistance, this current, instead of being a straight line, when I will increase the voltage, this current starts falling down. So I will get something like, so this current will not remain same, it will become zero. Similarly, this current will not be same. After some time, it will like fall, it will become zero. And similarly, like this. So now this is very clear to us that we can easily feel it. Like if I talk about VI characteristics of power sources in a DC circuit, because of resistance, the voltage and current, its value will not remain constant, but with time it will keep on decreasing. So this is like a general graph which is showing the behavior. If I talk about I1, we can see it will not remain constant, but it will decrease. It will fall to zero. I2 will decrease, fall to zero. I3 will decrease, and fall to zero. And similarly, if you look the other way, V1 should be constant. With time, V1 will fall and it will become zero. V2 will fall, decrease, it will become zero. V3 will fall, it will decrease. So this is the idea.